Hello and welcome to another episode of Math 95 Online. This video is covering section 6.6 out of the Math 95 book for Columbia Gorge Community College. And this section is about story problems or modeling with proportions and variation. In this lesson, we're actually going to kind of go opposite of the title and start with variation, and then we'll talk about proportions later. So we have some definitions today that we want to talk about. So, and these definitions are in your book, but I want to just clue you into some key vocabulary that is going to help you tremendously if you understand it in doing these story problems. So we have three different types of variations. We have direct variation. We have inverse variation. And we have joint variation. For direct variation, whenever you hear something say y varies directly as x, or y varies inversely as x, you should think of the equation y equals kx. And then if you read something that says y varies inversely, that's y equals k divided by x. And jointly means that you have more than one thing that you're varying directly as. So that's going to be k times maybe x and not y, but z. So again, this first one says, but we'll try in green, y varies directly as x, and that would give you y equals kx. This one says y varies inversely as x, and this one says y varies jointly as, there's an L in there, jointly, it works, as x and z. So those are the basic formulas that go with all the types of variation that we'll learn. And you're going to want to know in a story problem, as it says y varies directly as x, you should think in your head very quickly y equals kx. Some other language that I want to mention involving these is how variation is related to proportions. And so in your book and other books, sometimes they use this, sometimes they don't, talks about direct variation, also using the vocabulary directly, directly proportional. So if you heard that vocabulary, you would also think y equals kx. This you would hear or read inversely proportional. And we don't really say jointly proportional. We would say varies jointly. But directly proportional and inversely proportional are synonymous with direct variation and inverse variation. Okay, so let's have an example using this, and you'll see how it works. So let's say that y is inversely proportional to x. This is the same thing as saying y varies y varies inversely as x. So we could also say that y varies inversely as x. So these are the same statement, and that should give us the equation y equals k divided by x. So we should be, as soon as we read that, we should be thinking y equals k divided by x. Then we could get something that says y equals 2 when x equals 30. Find x when y is 5, let's say. Find x when y is 5. So all of these problems work the same. The first thing you do is you need to think of this equation, and then you use this information to find k. K is called your proportionality constant, or your constant of variation, and we need to know that. And then once you have k, then you plug in 5 for y and you'll figure out what x is. So let's do that first. First we're going to find k. Find k. So to do that, we're going to plug in, so y equals 2, we don't know k, and x is 30. So to solve for k, we're going to multiply both sides by 30 times 30. So we get 60 equals k, right? Because these cancel out. Now, since we have k, we're going to plug that back in for k in the original problem, and we have our equation for this situation. So we have y equals 60 divided by x. Y equals 60 divided by x. Now we're ready to figure out, our question asks us find x when y is 5. So we're going to plug in 5 for y. We have 60 divided by x, and figure out what x is. We can make 5 over 1 and cross multiply. So we have 5x equals 60, and then divide by 5, so x equals 12. And there you have it. All these problems work exactly the same. If you first come up with the equation that you need based on the situation. So in this situation it was y equals k divided by x. Then you use the first set of information to find k, plug k back into your equation, and use the rest of your information, in this case it was y equals 5, to figure out what you're missing. And that's direct variation. Works the same for direct variation and for joint variation. The other thing that I want to show you out of this this section in the textbook is proportions. So we could talk about like similar rectangles. Similar means that they're proportional to each other. So if I draw two rectangles and I say that these rectangles are similar, even though they don't look very similar, what I'm saying, if this is R1 and this is R2, is that you could multiply R1 by some constant and you would get R2. Okay? So that means that they're proportional. One is just a scaling of another. So if we had a rectangle and another rectangle, and I said R1 and R2, and I said that R1 and R2 are similar, or this is proportional, and I said that this was 10, and this was, how about 5? I understand that it's not drawn to scale, okay? And I said that this was 5, and this was x. Find x. That could be the problem. And then we can just set up some proportions to solve this. So what we would do is we could say that as long as you set up your proportions to where the sides, the top and the bottom for each proportion have the same units or are corresponding to the same side of each object, you're totally fine. So this side corresponds with this side, right? So I could say 10 divided by 5 has to be equal to this side divided by this side. So 5 over x. And then we can just solve it by cross multiplying. So 10x equals 25. Divide by 10, divide by 10, x equals 2.5. And then that's it. That's it for proportions. Proportions can be used to solve many different types of problems. And as you take a look at section 6.6, you'll see that there are many story problems involved here that can be solved using proportions. I'll do another example, just one out of the book for you. This is going to be number 27. Okay, number 27 on page 470 says if you earn $78 in 6 hours, comma, you earn X dollars in 8 hours. So you're supposed to solve for X by using a proportion. So here, when we set up our proportions, we want to make sure that we're using the right units. So you don't have to do this every time, but I'm gonna put money on top and hours on the bottom, and I'll write that just to remind myself. So $78 in 6 hours has to be X dollars in 8 hours. Okay? And then you just cross multiply. So as we cross multiply, we have 78 times 8 equaling 6x. 78 times 8 is 624. And then we'll divide by 6. So x equals $104. So if you make $78 in 6 hours, if you work 8 hours, you will have $104. And the rest of the proportions work just like this. So try a bunch of examples. If you're having a hard time, my recommendation would just be to keep doing them, and you'll totally get the hang of it. Good luck!